Hello students, welcome to Saurav sir's classes. The first question is, three urns contain respectively 3 green and 2 white balls. So there are 3 urns, U1, U2 and U3. So the first one contains 3 green and 2 white balls. That is 3 green and 2 white balls. So the second one has 5 green and 6 white balls. 5 green and 6 white. And the third one has 2 green and 4 white balls. So 2 green and 4 white balls. One ball is drawn from each urn. Find the expected number of white balls drawn out. So first, let us define xi, x is a random variable, xi to be 1 if the ball drawn from ith urn is white and 0 otherwise. Now let S be the sum of all the xi's. So S is equal to x1 plus x2 plus x3. So now we need to find out the expected number of white balls drawn out. So expectation S is equal to expectation x1 plus x2 plus x3 is equal to expectation x1 plus expectation x2 plus expectation x3. So now, since we can draw one white ball in one draw, so 1 into probability that the white ball would be drawn from the first urn is 2 by 5, since we have a total of 5 balls over here, plus 1 into 6 by 11, since we have 6 white balls and 6 plus 5, 11 total balls. And similarly for the third urn, 1 into 4 by 6, since we have 4 white balls and total of 6 balls. So this comes out to be 2 by 5 plus 6 by 11 plus 4 by 6, and calculating this, actually summing this and simplifying it, it comes out to be 266 by 165. Therefore, the expected number of white balls drawn out is 266 by 165. Moving on to the next question. A player tosses 3 fair coins. He wins rupees 8 if 3 heads occur, rupees 3 if 2 heads occur, and rupees 1 if 1 head occurs. If the game is to be fair, how much should he lose if no head occurs? So for a fair game, expectation x is equal to 0, where x is the sum on reward, that is the amount you receive or you need to pay if you win or lose respectively. So first let us construct a table for x. I am extremely sorry students for the inconveniences on the screen. So as I had said, for a fair game, expectation x should be is equal to 0. Now let us construct a table. It would be easier for us to understand the sum x, which is the amount you would be getting or losing, 8, 3, 1 and a. Then number of heads 3, 2, 1 and 0. And so what is the probability of each event occurring? This is actually 3c3 half cube half to the power 0. So it's actually 1 by 8. For 2 heads occurring, the probability is 3c2 half squared into half to the power 1, which is 3 by 8. For 1 head occurring, 3c1 half to the power 1 to half squared is equal to 3 by 8, and for no head occurring, it is 3c0 half to the power 0 into half cube, which again comes out to be 1.8. So now we need to calculate expectation x is equal to 0. So expectation x is equal to summation xp is equal to 8 into 1 by 8 plus 3 into 3 by 8 plus 1 into 3 by 8 plus a into 1 by 8. So this comes out to be 1 by 8, 8 plus 9 plus 3 plus a, which is 20 plus a by 8. Now for this to be a fair game, this needs to be equal to 0, or 20 plus a is equal to 0. So a is equal to minus 20. Thus, if not a single head occurs, that is, we get all the 3 tails, then the person would be losing 20 rupees for this to be a fair game. Moving on to the next question. A coin is tossed 4 times. Let x denote the number of items a head. The number of times a head is followed immediately by a tail. Find the distribution, mean and variance of x. So here x denotes the number of times a head is followed immediately by a tail. So first, what is our sample space when 4 coins are tossed? So it goes as such: H, 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 where H represents a head and T a tail. H, 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 T, H, H, T, H, H, T, H, H, T, triple H, again H, H, T, T, H, T, T, H, T, T, H, 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 T, H, T, T, H, T, H, double T, double H. Then we have T, 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 H, T, T, H, T, T, H, T, T, H, triple T, and all tails. So here we get the 16 combinations. Let me check once again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. So now let us create a table for x and its corresponding probability. And let us define, so Is there any chance that a head is not followed by a tail? So x would be 0. And if we notice, so for the first one, yes, and everywhere else a head is followed by a tail. Well, actually not. Well, if we'll analyze, then we get 5 such situations where a head is not followed by a tail. So the probability becomes 5 by 16. Next, x comes out to be 1, where a head is followed by a tail is exactly 1 time, and this comes out to be 10 by 16. And say a head is followed immediately by a tail 2 times, we get this case, that is this one, HTHH. So every time you get a head, you get a tail the next time. So this occurs only once. So 1 by 16. Now expectation x comes out to be summation x into px. So 0 into 5 by 16 plus 1 into 10 by 16 plus 2 into 1 by 16. So this comes out to be 10 plus 2 by 16, actually 12 by 16 is equal to 3 by 4. Expectation x squared is equal to summation x squared px. So 0 squared into 5 by 16 plus 1 squared into 10 by 16 plus 2 squared into 1 by 16. So this comes out to be 10 by 16 plus 4 by 16, which is actually 14 by 16, so 7 by 8. Now variance x is equal to expectation x squared minus expectation x whole squared. So 7 by 8 minus 3 by 4 squared, and this comes out to be 5 by 16. Thus we get the distribution over here, and our mean is 3 by 4, whereas variance is 5 by 16. Moving on to the next question. An urn contains balls numbered 1, 2, 3. First a ball is drawn from the urn, and then a fair coin is tossed the number of times shown on the drawn ball. Find the expected number of heads. So first let us actually understand the sum. You draw a ball, say 1, 2 or 3, and then you toss the coin the number of times the number is shown on the ball. Say you draw ball number 2, so you toss the coin 2 times. Say the ball number 3 came out, then you need to toss the coin 3 times, and then you need to find out the expected number of heads. So first let us define Bj to be the event of drawing out the ball number j. So Pbj is equal to 1 by 3 for j is equal to 1, 2 and 3, because each ball has an equal probability of being drawn out, so it is 1 by 3 of each ball being drawn out. Now let x represent number of heads shown. Where x can range from 0 to 3, that is 0, 1, 2 and 3. Now probability that x is equal to a number, say 0, 1, 2 or 3 is equal to j is equal to 1 to 3, probability bj to probability x is equal to x given bj. So this is actually 1 by 3 summation probability x is equal to x given bj. So now let us calculate probability x is equal to 0, and I'll explain to you how we get this term. So 1 by 3 into probability x is equal to 0 given the first ball is drawn plus probability x is equal to 0 given b2, that is the second ball is drawn, plus probability x is equal to 0 given b3, that is the third ball is drawn. So 1 by 3. Now x is equal to 0 given b1. So given one ball is drawn, what is the probability that the head doesn't occur? It is half. Plus x is equal to 0 given b2. Given that ball b is drawn, ball 2 is drawn, that is you toss a coin 2 times, and given x is equal to 0, you don't get a single head. The probability is 1 by 4. And probability x is equal to 0 given the third ball, so you toss a coin 3 times and you still don't get a head, is 1 by 8. So this comes out to be 7 by 24. Similarly, probability x is equal to 1 is equal to 1 by 3 probability x is equal to 1 given b1 plus probability x is equal to 1 given b2 plus probability x is equal to 1 given b3. So this comes out to be, now again, given the first ball was drawn, that is you need to toss a coin 1 time. So the probability of getting a head is half. For this thing, ball 2 was drawn, so you need to toss the coin twice, and the probability of getting 2 heads is 2 by 4, and given you toss the coin 3 times and you get only 1 head, it is 3 by 8. So this comes out to be 11 by 24. Similarly, probability x is equal to 2. We'll follow the same pattern over here, and we get this to be 1 by 3, 0. 0, since when ball 1 is drawn, you can't get 2 heads, so it is 0. Plus, when ball 2 is drawn, you flip the coin twice, and probability of getting 2 heads is 1 by 4. And again, for the third ball, the probability of getting 2 heads is 3 by 8. Since it is the third ball, you flip the coin thrice, that is you toss it thrice, and 3 by 8. So this comes out to be 5 by 24. Now probability x is equal to 3 is 1 by 3 into 0. Again, for ball number 2 also it is 0, because if you toss the coin twice, you can't get 3 heads, and it is 1 by 8 for the third ball, so it is 1 by 24. Now expectation x is equal to summation x px. So this is actually is equal to 0 into 7 by 24 plus 1 into 11 by 24 plus 2 into 5 by 24 plus 3 into 1 by 24, and this comes out to be 11 by 24 plus 10 by 24 plus 3 by 24, that is actually 24 by 24, is equal to 1. So expectation x is equal to 1.